Hello everyone, today we are going to look at another LeetCode problem called best time to buy and sell stocks. Let us look at the problem definition. You are given an array prices where prices at I is the price of a given stock on the ith day. You want to maximize your profit by choosing a single day to buy stock and choosing different day in the future to sell that stock. And the goal is to return profit that you can achieve from this transaction. If you cannot receive any profit, return 0. Let us look at this example to understand. Here the prices are given as 715364. So if you buy the stock at the second day at the price of 1 and you sell the stock at the fifth day at the price of 6, so the difference between the price is 6 minus 1 equal to 5, which is the maximum profit you can get from this set of values in the array. If you choose any other values, for example 1 and 3, you're gonna get 3, and 1 5 and 4 you're gonna get 1. Any other pair will give you lesser amount than 5. Look at this second example here. If you notice, the array is sorted in descending order, so whichever price you're gonna buy the stock, you're gonna definitely sell it at a lesser value, so you cannot get any profit out of this array, so the output will always be 0. Now since we have looked at the problem definition, we can move on to the solution. So we will talk about two algorithms here, the brute force and another optimized version. The brute force algorithm is like this. You're gonna iterate through the entire array, and for each element you're gonna again iterate through the remaining elements after that particular element, and you're gonna check if the value of profit achieved is greater than whatever you have achieved so far. So if you did not understand, I'll walk through the algorithm once to make things clear. So suppose we start from here. Okay, as per the algorithm, we will set the value of profit to 0 initially, and we'll start from here, and for each element of the array, 7 in this case, we are gonna again iterate through the remaining array and check if the value of profit is greater than the existing value. Okay, so yeah, for 7 we are gonna compare with 1 first. So 1 minus 7 is equal to minus 6, so this is a negative value. So if you buy at 7, you should definitely not sell it to 1. So if it is lesser than 0, we are not gonna update profit. And then again you move to 5. Again 5 is lesser than 7, so we are gonna not update profit. 3 is lesser, 6 is lesser, 4 is lesser, everything is lesser than 7. So whatever price you buy after buying at 7, whatever price you sell after buying it at 7, you're gonna be at a loss. So let's move on to the next element now. So the next element is 1. Again we're gonna do the same thing. So for 1 we go to this position at 5, see if 5 minus 1 is greater than 0. It is greater than 0 or greater than profit. The value is 4, so we're gonna replace 0 with 4. Now 3 minus 1 gives 2, and so 2 is lesser than 4, so we are not gonna update profit. 6 minus 1 is 5, so we are gonna update profit because 5 is greater than 4, and 4 minus 1 is 3, which is not greater than 5, then we're not gonna update it. Similarly, after 1 we again come to 5. We again come to 5, and again for 5 we are gonna check the value with the remaining arrays again. So 3 minus 5 is negative, so not gonna update. 6 minus 5 is 1, not gonna update profit because this 1 is lesser than 5. 4 minus 5 is again a negative number, not gonna update profit. So finally 5 is our answer. But what is the time complexity of this algorithm? That is O of n square, because first you're gonna update through this outer array. For each element you're gonna again iterate through the remaining portion of the array, right? For 7 you're gonna update through all these values, iterate through all these values. Then for 1 again you're gonna iterate through all these values, and for 5 again iterate through these. For 3 you're gonna iterate through these. For 6 you're gonna iterate through the remaining, which is only one element. But still the time complexity is O of n square, and we can definitely do better than this algorithm. So let's see what is a more optimized algorithm. Now we are gonna look at the second algorithm. This is pretty simple. We are gonna maintain two variables here, profit and another one called min, which is not here. Let me add that. Another one called min, and this time we are gonna iterate through the array only once, and we are gonna check if the value of that particular element of the array is lesser than the value stored in min. If it is lesser, then we are gonna replace the value of min by that particular element of the array, and we are gonna then subtract that particular element with the value of min and see if it is greater than profit. If it is greater than profit, then update the value of profit accordingly, and then we are gonna return the value of profit. If you are confused, let's look at the algorithm, then probably you will understand. So we are gonna start from 7 again and set the value of profit as 0 and min as prices at 0.7. So since we have set the value of min as 7, we can directly start from the remaining portion of the array. So from here we're gonna start. So the first value is 1, so we are gonna check if the value of 1 is lesser than the value of min. So definitely 1 is lesser than 7, so we're gonna update 7 with 1. Then we're gonna see if e minus min is greater than profit. So e minus min means, what is e here? E is this particular element. So 1 minus 1, the value is 0. It is not greater than profit, so we don't do anything. We move to the next element, so which is 5 here. Now for 5, the value of min is 1, so 5 is not lesser than 1, so we're gonna not update min. And also 5 minus 1 is equal to 4. So since this is greater than the present profit, we're gonna update the value of profit with 4. Now we are at the next element, which is 3. Is 3 less than min? It is not less than min, so not updating min. But is 3 minus min, which is 2, is 2 greater than profit? It is not greater than profit, so we are not gonna update profit. Now we are at 6. Is 6 less than min, which is 1? No, so we are not gonna update min. Is 6 minus min, which is 6 minus 1 equal to 5, greater than profit? Yes, it is greater than profit, so we're gonna update profit. Now again we have 4. 4 is 4 less than min? No. Is 4 minus 1, which is 3, greater than profit? Profit is 5, so definitely no. So we have iterated through the whole array, and now we are gonna return the value of profit, which is 5. So the time complexity of this algorithm is O of n. So that's how you solve this problem in linear time. Now let's look at the code. Let me increase the font size first. Yep. So this is a pretty simple code. So as described in the algorithm, we will set two variables. First is called profit. We're gonna assign it to 0. We're gonna set another variable called min. We're gonna assign it to first element of the array, prices at 0. Now we're gonna iterate through the remaining portion of the array, so we can start directly from 1, and if I is less than prices dot length, and I plus plus. Then what are we gonna do? We have two conditions here. If the value of this particular element, which is prices at I, is less than min, then what we are gonna do, we are gonna update the value of min with prices at I. Now there's another condition. If the value of prices at I minus profit greater than present value of profit, then you update profit equal to prices at I minus okay, one mistake. You are going to do prices minus min, because min is the minimum price of the stock that you could buy a stock in. So again, profit equal to prices minus min, that's what you're gonna set if value of prices minus min is greater than profit. Okay, so we are done with the algorithm. The only thing remaining is to return the value of profit. So the same thing that we were doing in algorithm, we check if the value of prices is less than min. If it is less, then updating the value of min, and again checking the value of prices minus min. If it is greater than profit, then we are updating the value of profit. So let's run this code to see if I have made some compilation errors. Nope. So let me submit this. Okay, so it is submitted successfully. So that's all for this video, guys. See you in the next video. Thanks. Bye.